Before we can calculate probability and odds, we need to be able to count up all of our options. This brings us to the multiplication rule, permutations, and combinations. Let's begin with an example. Suppose we have a class of 20 students, and 3 will be selected at random to serve as president, vice president, and secretary. In how many different ways can this be done? We're choosing 3 students for 3 different roles: president, vice president, and secretary. Since these students are being chosen at random, you can picture the teacher pulling names out of a hat. When she draws the first name, think about how many options there are. If there's 20 students and 20 names in the hat, there's 20 options for president. Now, unless the same student could be chosen as president, vice president, and secretary, once that president is chosen, there's only 19 options left for who could become vice president. And once that name is chosen, there's only 18 students left to choose from for secretary. So we have 20 options for president and 19 options for vice president and 18 options for secretary. When you hear the word "and," that's often a clue to multiply. And multiplying these 3 numbers together, we find that there's 6,840 different ways that 3 students can be chosen out of 20. In this example, we use something called the multiplication rule. The multiplication rule states that if there's m different ways to do x and n different ways to do y, then there's m times n different ways to do x and y together. We had 20 different ways to choose a president, 19 different ways to choose a vice president, and 18 different ways to choose a secretary. So we could multiply those 3 together to find out how many different ways there were to choose all 3 together. This is also an example of a permutation. A permutation is an ordered selection of a certain number of objects chosen from a set. We typically use the notation of NPR, where n is the number of objects to choose from and r is the number that we are selecting. A key word here is the word ordered. Order matters in this situation. If we chose the same 3 students but in a different order, then that's a different president and a different vice president and a different secretary. With permutations, order matters. In our example, we had 20 students to choose from, so n is equal to 20. We were choosing 3 from the 20, so r is equal to 3. So using permutation notation, we wanted to calculate NPR, or 20p3. The way that we arrived with the number 6,840 is perfect. But if we want to use permutation notation and its formula, NPR is equal to n factorial divided by n minus r factorial. Substituting 20 for n and 3 for r, we have 20 factorial divided by 20 minus 3 factorial. You can use your calculator for this, but I'll quickly show you how this is equivalent to what we've already done. 20 factorial is equal to 20 times 19 times 18 times 17 all the way down to 1, while 20 minus 3 factorial, or 17 factorial, is 17 times 16 times 15 all the way down to 1. And simplifying, notice that all factors of 17 through 1 are in both the numerator and the denominator. So they all simplify to a factor of 1, leaving us with just 20 times 19 times 18, which is exactly what we came up with intuitively, or 6,840. Let's look at a different kind of example. Suppose you're being dealt a 5-card poker hand. In how many different ways can this be done? Let's start by setting this one up in the same way that we set up our class officers. Let's call the 5 cards we're going to receive card 1, card 2, card 3, card 4, and card 5. With 52 cards in a deck, you could consider that there's 52 cards to choose from for your first card. And once that card has been chosen, there's 51 left to choose from for the second card. That leaves 50 cards left as options for the third card, 49 for the fourth, and 48 options for the fifth. Multiplying these together, we find a total of 311,875,200 ways that this can be done. But there's just one problem here. Suppose these are the 5 cards you're dealt: a 4 of clubs, 5 of spades, ace of hearts, jack of clubs, and a 7 of diamonds. When you're handed the cards, you can shuffle them around however you want. In other words, this is exactly the same hand as if you were given the 4 of clubs first, then the 7 of diamonds, Jack of clubs, 5 of spades, and last the Ace of hearts. So these aren't two different events or two different ways to be dealt 5 cards. With any reorderings of the same 5 cards being the same hand, we need to account for these duplicates. Our number is way too high. Let's take this hand as an example and see how many different ways it can be given to us. For any group of 5 cards, we would have 5 choices for the first card given to us, which leaves 4 choices for the second card given to us. 3 choices are then left for the third, 2 choices left for the fourth, and then there's only 1 card left for the last choice. This means that every hand of 5 cards could be reordered in 5 factorial different ways, or a total of 120. That's 120 different orderings per hand of 5 cards. So now let's recalculate how many different ways this can be done. In our number of 311 million, every group of 120 is a repeat. So to find the number of unique hands, we'll take our total number, 311,875,200, and divide by 120. This gives us a much more reasonable answer, but still huge, 2,252,960. That's how many different ways you can be dealt a 5-card poker hand. This is an example of a combination. Combination is an unordered selection of R objects chosen from a set of N objects. The key word here is unordered. In this situation, the order of the cards did not matter, so we needed to treat this situation a little differently from the last situation where order did matter. Let's take a look at how combinations are calculated. Similar to permutations, we use the notation NCR for a combination of R objects chosen from a total of N objects. In our example, we had 52 cards to choose from, and we were selecting 5 of them. The way that we calculated the number of 5-card hands was great, but if you want to use your calculator with the combinations function, or simply use the equation for combinations, it works like this. The number of combinations is n factorial divided by n minus r factorial times r factorial. So with our 5-card hand example, with 52 as n and 5 as r, we have 52 factorial divided by 52 minus 5 factorial times 5 factorial. Notice that what we started out doing was treating this like a permutation, which is equivalent to 52 factorial divided by 52 minus 5 factorial. That's where we got 311,875,200. What we needed to do was divide by our repetitive hands, and we divided by 5 factorial, or 120. This changed it from a permutation to a combination, and gave us 2,592,960. In other words, using the combinations formula gives us the same value as when we calculated this intuitively. That concludes this lecture video on counting. We talked about the multiplication rule, permutations, and combinations.